few homework questions I wanted to review here based on some emails. So question 9, the Kp for the reaction A going to 2B is 0.045. What is the Kb for the reaction of 4B going to 2A? And so when we calculate this, right, it's always concentration of products over concentration of reactants. So for the first reaction, A goes to 2B, we know that Kp is 0.045. So for the second reaction, we're given 4B goes to 2A. Well, what happens if we just flipped the first reaction and said 2B goes to A? Flipping the reaction is the same as flipping the numerator and denominator in the Kp value, right? Because now our reactants are products and vice versa. So if we do the inverse, 1 over 0.045, right? That would be our new Kp for this reaction. But we're not asked 2B going to A, we're asked 4B going to 2A. And when we change the exponents, right, that changes our expression. So now our expression would be partial pressure of A squared over the partial pressure of B to the fourth. So basically what we've done, right, the normal reaction would have just been partial pressure of A over partial pressure of B squared. We've basically squared the entire expression because I've changed this exponent in my new reaction. So that means I need to do the same to my equilibrium constant. So my new equilibrium constant for this reaction would be 1 over 0.045 squared. So if I plug it into my calculator, I get a Kp of about 494 for this reaction. So this problem goes a little bit farther than what I would ask of you. I would stop right here. So if you know the reaction, I would expect you to know that the reverse reaction would simply be the inverse. So the forward reaction, A going to 2B, it's got a small Kp value. It's not favorable, which means the reverse reaction should be favorable, right? 1 divided by 0.045 gives me a Kp of like 22. So that you should know. The second part here is a little bit beyond what we would do or what we would see in an exam situation. Question 18 is also a tricky question. They tell us we've got an empty steel container filled with 3 atmospheres of hydrogen, 3 atmospheres of fluorine, and it's allowed to reach equilibrium. Kp is 0.45 for the reaction. What is the equilibrium partial pressure of HF? So to answer this question, we'll start with an ice table. We've got hydrogen, fluorine, and HF, right? Our initial, our change, our equilibrium. So initially, right, I've got 3 atmospheres of hydrogen, 3 atmospheres of fluorine, and I've got 0 atmospheres of HF. As this reaction goes to equilibrium, I'm going to lose X amount of hydrogen, X amount of fluorine, and I'm going to make 2X amount of HF. So now I can figure out my equilibrium. So the questions we did in class, we were told one of the equilibrium concentrations and use that to work backwards and find the change, and then we could find all of the equilibrium concentrations based on that. This is more of an algebra problem and less of a chemistry problem. So again, on the exam, I would give you one of these 3 concentrations. They don't do that here. So we're going to set it up as an algebra problem, right? So this would be 3 minus x, this would be 3 minus x. Our expression for this, right, Kp would be the partial pressure of HF squared because of that coefficient of 2, divided by the partial pressure of hydrogen times the partial pressure of fluorine. Now we're going to plug in what we know. So I know Kp is 0.45. I know HF is 2x squared. And I know hydrogen is 3 minus x, and I know fluorine is 3 minus x. So if I multiply those two together, I'm going to multiply these two together right here. I get 0.45 equals 2x squared over 3 minus x squared. So again, this is more like an algebra problem, less like a chemistry problem, so I apologize. We'll notice that we've got both of these are squared, so I can get rid of that and make our life a little bit easier by basically taking the square root of both sides. Taking the square root of both sides, so the square root of 0.45 is 0.6708. That equals 2x over 3 minus x. Now I want to try to get x by itself, so I'm going to multiply both sides by 3 minus x. So I'm going to multiply 3 minus x over here. It cancels out on that side, and that's going to leave me with 3 times 0.6 is 2.01 minus 0.608x equals 2x. Again, we're going to try to get x by itself, so I'm going to add 0.6708x to both sides, so that gets x on the same side at least. Going to have to move up top. So up top I get 2.01 equals 2.6708x. Again, I'm trying to get x by itself. I'm going to divide both sides by 2.6708, 2.6708. That cancels out here. And I'm going to get a value of x of approximately 0.7535. Now you went through all of those steps, right? We're not done, unfortunately. Because if we go back and look at our ICE table, we'll see we're looking for HF, and HF was not x. HF was actually 2x. So 2x equals HF. So that means 2 times 0.7535 equals HF. Multiply this by 2, and I should get something like 1.51 ATM. So again, this is more like an algebra problem and less like a chemistry problem on the exam. I would definitely give you one of these equilibrium concentrations. We would use that to find the change, and then once we found the change, we would use that value, x, to basically apply that to all the concentrations so that we could find equilibrium concentrations for everything. This question went a little bit beyond that in that they didn't give us one of those equilibrium concentrations, so we had to do a little bit of extra work to find those concentrations. So again, on the exam, you would definitely be given one of these equilibrium concentrations. We set this up in terms of x. You find x, use that to find the equilibrium concentration of all of these. So hopefully that helps with these two questions on the homework.